Very often when you're getting started in Cavalry, the main thing that you're trying to do is this procedural movement on shapes that creates a kind of organic sense of random movement. I know I personally was looking for this kind of core technique to do this when I started out, and in this tutorial I'm going to go over the most fundamental ones that I found to do this very simple kind of look. The ingredients we're going to be using are a basic shape layer for the ellipse and a duplicator, a color array utility, the noise behavior to drive a subtle position and scale change, the blend submesh behavior to morph between duplicator setups, and then a falloff to create this wave-like effect. In the first section, we'll build this random movement grid, which is something that you see often. We'll then learn how to blend between two duplicator setups, and then we'll create this simple falloff animation on the duplicates. If you're new to Cavalry and you don't know about scenery.io, you should definitely check it out. It's full of tons of free scene files from the best Cavalry creators in the community, and it's the main way that I've been learning. But if you're interested, I'm also working on a full course for Cavalry. You can find out more about this at cavalrycourse.com. Let's start with our shapes. I'm going to hit Command Y to create a background shape, which has my default color, but you can change that here. Next, I'll add an ellipse shape and hold Alt to add it at the center of the comp. Now, the quickest way to add a duplicator for this ellipse is just to select it and then click the duplicator icon, but let's do it the manual way so that you can see how this is set up. I'll hit Command period, which will bring up the layer search bar, and then I'll search for duplicator. Inside the duplicator, we need an input shape. So I'll just drag this ellipse, and now we have the same thing. You'll notice at this point the original ellipse is hidden, and we only have the duplicates showing. This is a normal behavior. You usually don't want your source shape to be seen, but you can turn that back on here. Now, even though we can't see the original source shape, if we change its properties like radius or fill color, all of the child elements of the duplicator will change. However, if we try to change properties like position and rotation, then nothing is going to happen. And that's because the duplicator is now controlling all of these children elements. You can learn more about the specifics of this in Cavalry's docs. In the duplicator, we can now dial in the settings that we want, and I'm going to increase the size of the grid so that it fills out our screen. I'm going to hold Alt initially so that I can link the width and height parameters when I drag, and then I'll let go of Alt and drag the width so it covers the whole screen. Next, I'll hold Alt again so I can link these two X and Y parameters and increase the duplicate count. Now, I obviously want to reduce the size of the ellipse here, and I can do this in two ways. You can either go to the original shape, the original ellipse, and pull down the radius, again holding Alt here to link the two parameters, or if you want, you can go into the duplicator itself and change the shape scale. But because this is such a small value, just 1, I really recommend starting by dialing in the basics of your kind of radius or your scale inside of the original shape first, and then doing very small changes or behaviors on the scale value in the duplicator. So a couple more adjustments in the duplicator, and we have roughly the look that I'm after. The color array utility lets you create multiple different colors and then use those values to drive different things in your comps. Instead of setting one up and then adding them manually though, like this, a really quick way of doing it is just picking a palette that you like in the color picker and then using the create array from palette function over here. I'll pull this down, not because it does anything by having this layer at the bottom, but just because it's my preference. And then I'll drag from the output here to make a connection. Now, you can see that when I drag the output of the color array, the duplicator gets crossed out, and when I hover over it, the end of the connection turns red. This is basically telling me that there's nothing that I can drive in here with this utility. But the background shape and the ellipse shape are both able to receive it. So I'm going to drop it onto the ellipse shape, and Cavalry asks me which of the properties I want to drive, but obviously we only have one here. Later you'll see that there will be many when we drop onto when we drag one of these connections. So I'll just click fill color, and you'll see now that our duplicates are being colored by this color array in a really interesting way. Now, although this looks interesting, it doesn't necessarily look that random at the moment. We've got this kind of diagonal distribution or resulting pattern from the distribution, however you want to describe it. And there are a couple of ways that we can make this look a bit more organic. I personally don't think I need this white color here, so I'm just going to delete this particular color in the array as it stands out so much. And then I'll head to the duplicator and adjust my settings. And that actually kind of solves it for the most part. Sometimes you find there's a strange interaction between the number of array items in your colors and the particular number of duplicates in your duplicator. In that instance, it resulted in this effect that we didn't want, so it's just worth playing around. But you might be thinking, Jack, you just changed your original artistic decision to fit a limitation. What a terrible thing to do. That's a great point. So let's not do that. I kind of only showed you this rough way of fixing the issue to make a point about the way that you can work in Cavalry and the way that arrays and duplicates can interact visually. Cavalry is really all about plugging things into other things and just seeing what happens when you dial up and down settings. Often it's enough to be rough, but let's now go back and solve this in the proper way. So what's our problem? Well, the array is applied to each of our duplicates linearly. In other words, it goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, on, or more accurately, 0, 1, 2, 3, 4, 5, because arrays start with 0. Now, if that doesn't make sense, let me show you a cool feature of the viewport. If you click on this cog icon here and click Draw Debug Information, when you click on the duplicate, you'll see the index numbers of each duplicate. This shows you what's going on under the hood in relation to how Cavalry processes the array on the duplicates. So to make this really clear, I'm going to hit Command on my keyboard so I also can select the color array, and this will appear in my attribute editor while still selecting the duplicator. And we can see now that the number 0 duplicate has the number 0 in the array color. Number 1, number 2, etc., until we go back and repeat. And the visual problem we're seeing here is that the interaction between the number of duplicates we have and the length of the array creates this pattern. So let me just turn off Draw Debug Information. This may be really obvious to you now, but I found this interesting, so I'm just going to belabor this point a bit. So if we change the count of duplicates or the arrangement, we get these different patterns because this is a procedural setup. And this is a really powerful point because you might actually want to create animations off of this principle here. For example, this one's actually quite cool, but maybe you don't want to see a pattern. In fact, that's what this whole video is about. It's about not creating patterns. It's about creating random organic styles. So how do we make sure that we always get a random distribution from the array? Well, this is where I'm going to cheat slightly because I'm going to add in one more behavior that I didn't actually mention at the start of this tutorial. And that's because it's not really part of the main techniques here. And I'll explain what I mean by that in a minute. So if we turn off auto index in the color array, we just get the first array item applied to all of the duplicates. Hopefully that makes sense to you. And if we scroll this number here, the index number between the different values in our array, we can see that we're cycling through the different colors in our array. You can actually imagine that this would be a really cool thing to do in itself. This could be another animation. I often find this when I'm playing with Cavalry. If you're just dialing in different values in a behavior or something like this, you think up new animations you could do in that moment, and it's wonderful and distracting at the same time. So where was I? Yes, okay, I got lost. So what I really want to show you here is that every property can be driven by behaviors. This is something that Cavalry says a lot, which is connect anything to anything or everything to everything or whatever they say. And it might not be obvious at first, right? You might be thinking, okay, I need this to be random, but it hasn't got like a random feature, but actually you could create a random feature inside of here. So what we want is for this index number to be driven randomly for every duplicate. And we right click on this and choose behavior random. This index number is now being driven randomly for every duplicate. And we just created that. And we can see it, actually, this new behavior added in our layer stack, the random layer. And if we click into it rather cleverly, well done, Ian and team, the minimum and maximum of the value, the minimum and maximum of the random values have been applied to the same number of array items that we have, which is really cool. I think that's intentional. Must be. If we want to find a different look, we can adjust the seed value here and various other aspects. And if we want it to be more or less random, we can dial up the strength or down the strength. But I mentioned that this isn't really one of the main techniques, and this is an important point here. So I'm going to do something a bit strange. I'm going to hide this random behavior inside of the color array. Now, this doesn't do anything, and it might seem a bit weird to you. Why are you hiding things, Jack? But let me explain. Sometimes when you're working in Cavalry, you'll do something like this. You'll add a bit of a feature or functionality to an existing feature just to tweak it a tiny bit to fix something. In our instance, we had a color array. The color array didn't have a random setting, so we just kind of added our own. And the way that I personally want to continue thinking about this composition and indeed teaching it is that we just have a color array and I fixed a thing that doesn't really matter. Now that I've fixed it with that random layer, I don't care about it anymore. I'm not going to go in and dial settings, so I'm just going to hide it inside of this. And I'd recommend that you do this sometimes in your work just to reduce cognitive overload. Sometimes when you open up old scenes in Cavalry or you're designing new ones, it can actually get really overwhelming to see 15 or more layers stacked on top of each other and try and work out what on earth is going on. Hiding things or grouping things in this way can actually help you remember and keep a track of what layers are most important. And to finish, I am actually going to go back and delete that white color because I don't think it's working. Right, let's now dial in this noisy movement for the duplicates. As I said, this original ellipse is now no longer necessary when it comes to sort of properties like position, because all of these duplicates here are being controlled by the duplicator. So that's what we're going to be driving with behaviors. So I'll hit command period and search for noise. And after we add noise, you can see from this graph here that the noise behavior generates these random patterns in values that can drive attributes. And for us, we're going to be driving the scale and position of these duplicates subtly and randomly. Now, there are two primary ways to connect a behavior to a property. Possibly there are more, but the two main ones I'll show you now so that you can understand it in both ways. We've added the behavior first as a layer, and so we can drag its output to sort of point it to the duplicator. Now, this is what I mentioned earlier. Now we see this huge list here, and this is because the duplicator has so many different properties that we can drive with a behavior. Before we only saw one. Here I'll scroll up to find position and just let go. It's worth noting that I can also just let go on the X or Y if I wanted to drive these separately. And if I hit play, you'll see we have an issue. And I kind of did this on purpose to show you what I did in the beginning is I picked the wrong position property. I chose the main position, which is of course the whole duplicator. So what I'm going to do is I'm going to click on this little purple icon here on the noise layer, which shows me what property I'm driving, and I'm going to cross this out, which sort of removes that connection that we have. And we'll do this again. I'll pull out to the duplicator, and we'll see here that what we have in this huge list is the overall position up at the top, and that's what I did first, and then shape position, and that is what we want. Now we see that each of the shapes inside of this duplicator is being driven by the noise in a different way. Now, depending on what property you're driving, you're going to want to dial in the noise minimum and maximum differently. Because we're driving position here, we want to kind of have an equal distribution, if that's how you call it, of minimum and maximum. Otherwise, if you keep driving the maximum or pulling down the minimum, you're going to get this offset of the X and Y. I actually think for this particular subtle animation, -10 and +10 is great, so I'll just leave it there. But you can up the strength here, and that basically multiplies your effect. And actually keyframing this value is a really good way to ease in an effect from 0 to 100. So if your animation wanted to start out with nothing happening, you could dial this strength down and then bring it up to 100 or whatever you needed. So let's now add the other noise behavior, but we'll do this in the other way. Let's go into the duplicator, go to the shape scale property, and right click or control click. And you can see that we have a bunch of different things, but if we go into behaviors or add behavior, we can see this same list that we found in the search menu. And I'll click noise, and this is automatically connected now. But we've destroyed our animation, don't worry, we're going to get it back. So why is this happening? Well, if I do Command Z here and do it again, when you add a behavior to something, you get to choose whether you can drive the X or Y or both. And when you do both, the scale is being driven differently by the noise for the X and Y. In other words, the X and Y is not linked or being driven by one random value. But we can fix this inside of the noise behavior by clicking separate channels here or unticking it. Now everything is being scaled equally on the X and Y, but of course these values are too much. Now, if we go back into the duplicator settings here and scroll down to shape scale, if you remember before, in fact, let me Command Z a few times and go back to the state before we applied the behavior, we can see that the original shape scale is 1 because we dialed in our ellipses scale by doing it on the actual original shape here. So the duplicator's shape scale was always just left at the value of 1. But if we suddenly start driving this with noise, our noise has a minimum value of -10 and a maximum value of 10, which is obviously huge and really, really small, which will make it just disappear. So what we really want to do is to drive the scale, which starts at 1, something subtle, like from 0.6 to maybe 1.2. So let's try that. 0.6 to 1.2. And now that is kind of the look that we're after. So I first learned this technique from a scene that Tristan Young put up on Scenery, and also a tutorial by the Video Shop here on YouTube. So just a big thanks to those two creators. You should definitely check out Tristan's work on Scenery and the Video Shop channel on YouTube. I've learned from them a lot. But I want to distill it here because I love teaching. It helps me understand it, and the more of this stuff, the better. So here we go. So the blend submesh behavior basically blends between the submesh positions of two shapes. Now, I don't have time in this tutorial to go into the depths of what that means. I'm still, learning myself. But essentially, the duplicates inside of a duplicator are submeshes or subshapes, maybe to put it even more simply. And the blend submesh behavior lets you transition between the positions of one set of submeshes to another set of submeshes. In other words, it helps you blend from one set of duplicates to another set of duplicates in terms of their shape or position or other properties. So anyway, let's do a simple example first so that you can understand this from first principles, because it took me a few moments to get it. Let me create a duplicator setup here with just 3 circles, and I'll make a copy of that duplicator setup and move it to the other side of the comp. And we'll go inside of the first duplicator, and inside of deformers, we'll choose blend submesh position. Now, inside of the blend submesh positions behavior or layer, we'll drag in the second duplicator as the destination shape, and we'll obviously hide that second shape because we don't want to see that second duplicator setup. What we're actually just using it for is to sort of be the second state that we want our blend submesh to move between. You don't need to worry about this next bit or what it means, but for this particular setup, I do need to click global positions for this to work. And then if we pull the blend across, you'll see what the behavior is doing. It's basically moving between the positions it found in the first duplicator and the positions it found in the second duplicator. Now, this is a really boring animation deliberately, so we can understand first principles, but you can imagine now how the beautiful animation we saw from Tristan Young's work and how many other animations that you've seen can be done procedurally with this technique. You are not having to do individual keyframes on individual dots to get everything into the state that you want. I've done this so much in After Effects over my life, and this is just a very, very exciting principle. Now, before we get into the proper setup, one important point to know about blend submesh positions is that you need to have the same number of duplicates for this to work. Again, to show this in a really simple way, I'm going to head back to the first duplicator and increase the count to 4, but leave the second duplicator at a count of 3. And now, when we blend our submesh positions, the 4th duplicate, oh, sad, gets left behind. This is obviously something to consider when you're designing animations, and there's quite an easy way to make it work visually. So let's head back to our composition and duplicate this duplicator. Now, I'm going to change the distribution of this duplicator to be Fibonacci, and I'm going to rename them by hitting enter on each of them. And I'm going to hide the destination duplicate. I'm going to hide the destination duplicator because, yeah, we do not want to see this. We're just using its position data to then sort of like manipulate the original set of duplicates. Now, as I showed you before, you can add the blend submesh position here in the original duplicator, but what I'm going to do is show you the other way around again, just so if you're a beginner, you can really understand this, this other way of doing it. I'm going to search for blend submesh positions, and I'll drag the output of this deformer, or behavior really, terminology is confusing sometimes, and I'll put it here. I'll connect to a new index, and this is just another way of adding a behavior or deformer to an object. Now, in the blend submesh layer, I'm going to pull in the Fibonacci as the destination shape, and you're going to see something interesting now when I drag this. Again, it's the same principle. Only some of the original duplicates are moving, and I'm sure you can guess why. That's because if we hide the original grid and show the Fibonacci, the number of duplicates changed when we changed the distribution. In other words, in the Fibonacci distribution, we have a count of 50 duplicates. But if I hide this and show the grid and turn on draw debug information, we can see that the grid has 111 duplicates. This happens often when you're doing blend submesh on duplicators. And a really easy way to fix this is just to blend to the final state, and then in the destination shape, dial in the number of duplicates until they've all moved to the final position. Or as I said, you can open up draw debug information and work out how many you need. So I'm going to dial in the radius that I want for this Fibonacci, and all we need to do is to set a keyframe on the blend property here so that we move from this position to this position. And I'll set the easing using the curves plugin from Scenery, but you can do this just by right-clicking and doing magic easing, slow in, slow out. Now, there's something that I don't like about this animation as I play around with it. Here it looks great, it looks noisy, and then here we have this kind of strange sort of pattern-like interaction effect where the source shape and the destination shape are very obvious. It looks very obvious where we are going and it's like, oh, you're doing a procedural transition here. We can kind of see the Fibonacci and grid interacting here. It doesn't look organic or noisy. It just looks a bit naff. So what we want to do is add in some extra noise just in this middle transition moment to kind of hide what we're doing in terms of the technique. And the really easy way to do this is with our existing noise behaviors. Inside of our noise behavior that's controlling the shape position of our duplicates, I'm going to just keyframe the strength here so that it goes up really high during the transition moment and then back down when we land at the final state. And that is our animation. So for our final animation, we're going to create this really simple fall-off technique where you have the kind of general oscillation or sort of noise on the scale and rotation, on the scale and position, but then we can kind of limit or exaggerate the scale in a certain area, and this is called a fall-off. So let me show you how to build this up from scratch. So you saw there what we were at was sort of a 1.2 on the scale here, but what we want to do is kind of really exaggerate this a little bit. Let's go to 2.2 and then limit it so that the wave is really big where the fall off is. And just to be really clear here, what we're going to be doing is we're going to be creating a fall off on the noise, which is driving the scale. We're not creating this kind of a fall off effect on the scale itself. That's an important point. So we're going to go into the noise, which is driving shape scale. We're going to go to fall offs here, and I'm going to right click and add a fall off. And when I do that, you see that we lose all of the duplicates that are outside of that fall off. It's by default totally affecting everything outside of it. But you can see with this graph here, we can kind of flip that round, we can play around with it. And if we pull up this baseline, we get more what we're after. What we're essentially trying to do is affect the duplicates inside of the fall off, but not so much so that the ones outside of it totally disappear. So we'll come back to this graph in a little bit, but this is the fall off graph, and you're often going to want to play with this, including the Bezier handles as well, which we'll come back to in a sec. So let's go back to the general fall off settings, and what we can actually do is we can change this to different shapes. It can be linear as well, which is sort of just like a one-directional transition. What we want is rectangle because we want a wave, and you can either drag this fall off out like this, and I'm going to zoom out using my mouse wheel. I'm going to really increase the height of this about like that probably, and then what I'm going to do is I'm going to rotate it a little bit like that so that we have this wave going. And if I click on nothing and press F on my keyboard, I'm going to get back. So this is basically it, right? But all we need to do now is dial in the kind of the size of it. So let's have a bit of a wider size here. Let's dial in the Bezier a little bit so it's a little bit more, I don't know, gradual or less exaggerated. And that might be what we're after. I think I'm going to go back into my noise here, and I'm going to drag this down a tiny bit. Let's do 1.8. And then this is kind of what we're after. And all that remains to be done is if we go to the first frame and hold Alt on position and click, we're going to get keyframes there. I'm going to move that off frame. And then let's go over here. I'm going to zoom out a bit, and I'm going to drag it all the way over here. And then selecting both of these, I'll right click and do magic easing, or I could use the curves plugin. So let's try this out now and see what this looks like. Possibly a bit too fast, so I'll just drag these. And let's have a look at what we've got. It's nothing special, but it illustrates the technique that we're after here. So I want to show you one final thing, which is a kind of little tip or bonus to all of this kind of explorations you might be doing. As you're putting stuff out on social, you might want these kind of noisy animations to loop perfectly. But as you can see here at the end of the animation, there's no perfect loop because you can't control it, right? You can't sort of tell these duplicates where to be or to be the same. And well, in fact, you can. You can do it with this looping property. So let me show you how you do it. So if we do Command K, we can see that we have 249 frames. And if we go into the shape position, which is the one that we want to loop, and we hit loop and do 249 frames. And if we go to the shape scale and do the same thing, loop 249 frames, it will work. There's this weird thing that happens though, and I wouldn't be able to articulate it just yet because I'm still learning the real sort of core concepts behind Cavalry, is that everything speeds up. It's something to do with the fact that we're now driving time in a different way because of the loop. If someone knows the answer, they can comment below. But basically, all I do is I just go down and I make sure that the frequency is dialed down. So the frequency of our position now is too much. So I'm going to do 0.2. And if we see now, we're back to what we're kind of roughly the vibe we were at before. And if we hit play at the end, we can see that everything's seamless. So I hope this tutorial series has been useful for you. We covered a lot of stuff that I really wanted to know right off the bat when I first opened Cavalry. So I hope it's useful to you if you're a beginner just starting out. I'm only a few steps ahead of you, so hopefully you'll see new tutorials on this channel soon. Teaching really is just the best way that I learn. So let me know if you've actually watched to the end. It'll really encourage me to do more tutorials here. And that'll make me very happy to know that you've benefited from it. So I'll see you next time.